Okay, so I'm Celeste Scott. I'm your UT Horticulture Extension Agent, and I am in Madison County. So I'm there for you guys. If you ever have any kind of horticulture questions, you can seek me out, and I'm there for guidance and assistance, and you just feel free to call me anytime. Of course, we're not keeping office hours right now. We are all working from home, and that's why we have transitioned our Art and Garden lecture series to the Zoom. And I think everybody is doing so good using these new technologies. Like, everybody knows that they're already automatically muted, like y'all figured out how to share your video and turn your sound off. And so everybody's doing really well handling that. And I do appreciate y'all continuing to attend these meetings, and I'm having a great time hosting and speaking at some of them, and I hope y'all are learning a lot of new information. So let's just jump right in there, and if anybody could enter in the chat box or give me a head nod that you can see my slideshow presentation, Disease and Pest Control title page. Okay, good. I just wanted to make sure because I'm using a multi-screen situation here and wanted to make sure y'all were seeing the right one. So today we're going to talk a little bit, well, not a little bit, a lot of bit about natural and organic options for homeowners. And some of you might be thinking, well, what really is the difference in natural and organic? And there are some differences, and there's lots of different ways to define those. But a couple definitions that I really like to use come from this book. It's called The Organic Gardener's Handbook of Natural Pest and Disease Control. It's by Fern Marshall Bradley, Barbara Ellis, and Deborah Martin. And if you get this book, you will see why there are so many authors. It's because it is a textbook. I have it right here. It's a hardbound book. It's easy to read, easy to understand, but it is a reference book. It's not something that you would probably sit down and read, you know, like a novel. And I use it quite often. It was one of the first books that I got when I became an extension agent, and it has really helped me a lot with diagnosing and learning how to treat some of these pests when people don't want to go or would prefer not to go the synthetic chemical route. And so we're going to work our way up to treatment, but there's a lot of background involved before we get there. So I want to read you these definitions. A good definition of organic gardening from Natural Pest and Disease Control is: organic gardening is a method of gardening that uses our understanding of nature as a guide for growing plants without using synthetic chemical pesticides or synthetic fertilizers. So not either or right there, that's both. Natural gardening, on the other hand, could be defined as a method of managing pest and disease problems without the use of chemical pesticides and with an understanding that pests and diseases are part of a living system that has an innate balance. And that's pretty deep. There's a lot of things involved, from the microbes of the soil to those macro insects that are helping to improve soil health, and then those larger predatory insects that are providing some control options for us. So let's think about it in this way. If you're not opposed to using what we call synthetic chemicals, that's just regular, we'll call it traditional gardening. If you would rather not use synthetic pesticides and fertilizers, but you're not opposed to using some natural plant-based or nature-derived chemicals or nutrients, then that would be considered organic gardening. If you don't want to add anything and you are just depending on that plant to make it and for God to back you up on it, that might be considered natural, all natural gardening. So I just wanted to do a little clarification on those so we had a good understanding of what we're getting at. So organic gardening doesn't necessarily mean that you're opposed to using anything. There are some things that are labeled for organic use in home gardens that can be helpful in many situations. And like I said, that'll kind of be towards the end of the discussion when we get into what we actually treat things with. But before we get there, really the basis of organic and natural gardening, and truly traditional gardening as well, should be IPM, or integrated pest management. This is where we use several avenues to monitor what's happening in our gardens, teaching ourselves how to identify these diseases and insects, determining what our personal thresholds are for these aesthetic, how much they are affecting the aesthetics of our ornamental plantings or our edible foods, whatever that may be, determining those thresholds. And then we finally come to treatment options. And of course, especially in organic and natural gardening, our goal is to choose the least harmful action. We want to get the most control while also providing the least amount of environmental impact. We don't want to leave that footprint behind. And so within that, we have cultural, mechanical, biological control, and then finally chemical control. And I just noticed that there's a typo on the word chemical, so please forgive me. I'll fix that. So we're going to start off talking about our cultural, well, let me go back actually before we get there. So I'm briefly introducing you to the basics of IPM. We could have several more classes that just talk about all the skills and steps that are involved in monitoring our gardens and being able to identify insects and diseases. We don't have enough time for that today. So I'm just introducing that concept and the concept of thresholds, and we're jumping right to what are our treatment options. And we're going to delve into some of these different treatment options and how they can relate back to organic or natural gardening. All right. So the first one would be cultural practices. So this is, when I say we're stair-stepping it here, we're starting at the bottom. Least impact, there's no impact from these cultural practices. These are all things that we're doing on the front end, and I've titled this in the beginning because these are things that should be done well ahead of time. So of course, we want to promote healthy plants. A healthy and happy plant is more vigorous, and they're going to be able to withstand pest pressures. I'm not saying that they're going to, be immune to them or resistant to them. I'm just saying when those pressures and stressors happen, they are going to be able to deal with it better than, say, a plant that was already stressed with drought or low fertility issues or something in that situation. So we want to buy healthy plants. If you see leaf spots and discoloration or abnormal growth on a plant, don't buy it. Let's just start healthy, okay? So inspect those roots. Don't feel bad about pulling a root out of its container and checking those roots. Make sure we don't have girdling roots, and that the roots are nice and white and we don't have any, brown, mushy disease or anything like that. So let's start healthy. Let's plant smart. I feel like people have overused this term, the right plant for the right place. I'm so sick of hearing it, I don't even want to say it. So I've changed that, and I've said, let's plant smart, okay? We want to plant things where they'd like to be. If you've got a shade plant and you plant it in the sun and it gets leaf spots and dies, that was your fault. Because that plant is not a plant that was supposed to be grown in full sun. So if we take some really, consider our plant choices on the front end, we're going to be able to avoid a lot of these disease and even insect issues. Like, for example, azaleas. If you have azaleas, you've had azalea lace bug, whether you've known it or not. If you have azaleas that are in sun, you have definitely had azalea lace bug damage, because when those plants become stressed by being in that, we'll say, full sun type environment, the plant can survive, but it is stressed and it sends out a pheromone that attracts those azalea lacewing insects to that plant. So if you have a plant that's already stressed, it's going to be more prone, it can be more prone to drawing in insects that are specific to that species. So moving right along from there, we want to talk about resistant cultivars. I'll say we do have some resistance in some ornamental plants, but really where we want to, where we have focused resistance is in vegetable garden plants. Okay, so tomato plants, for example, I had a grower that sent me some pictures of some Indian River tomato plants, transplants that were in a greenhouse. He's a grower. And he was like, what's going on with this flat of tomatoes? I don't know what's going on. None of my other tomatoes have the same situation or showing these symptoms, and they've all been grown identically to one another. And it was a disease called verticillium wilt, which is a fungal disease. And lo and behold, Indian River is an older heirloom variety that does not have resistance to verticillium wilt bred into it. And when he told me what the other varieties were that he was growing, they were all F1 or F2 hybrids that had been bred for resistance. And so they were not showing the signs of this disease. And Indian River just happens to be susceptible. It was present in the environment and it contracted the disease. So resistance is especially important when we're talking about vegetable crops. And you can see in this little box outcrop on the slide there, I put an example of some resistance codes that you might see on vegetable labels. And this one is for tomatoes. There's lots of viruses and diseases that tomatoes can contract. And you see the very first one at the top. What is it? Verticillium wilt. So they've shortened them with 1 or 2 or 3 letter acronyms to represent each of these diseases. And in short, the more acronyms you have on a label, the better off you are because it's protecting against the highest number of diseases, even nematodes. Some have specific resistance to nematodes, which can be important because nematodes are very hard to, well, you can't eradicate a nematode, but they're very hard to manage once they become established in a planting area. Moving right down along, after resistant cultivars, we want to talk about sanitation. So if you have a home greenhouse, of course, washing your flats and your planting containers before you're reusing them each year is very, very important. You can use a bleach, water solution to wash those in. Vinegar can also be an option. I was reading that earlier today in a greenhouse grower manual. And so there are some options out there, but we want to make sure that we're cleaning our containers and getting rid of any kind of diseases that might be harbored from one crop over to the other. So sanitation is important, even for our planting and potting tables. And I'm not the best representative of that. I use an old wooden table. Wood is not easily cleaned. So, metal tables, wire shelvings, and racks, of course, are always good because they're going to let things fall down and move through them instead of harboring them from season to season. Then after we're talking about some of those initial cultural practices that we can put into place, let's talk about strategies that we can use on into our growing season and throughout. So crop rotation is a really big component of organic and natural gardening. And it should be in traditional gardening as well. However, sometimes it is not. But what we mean by crop rotation is that you need to rotate your major groups, or we'll call them families, of vegetable crops. Let me get a drink real quick. Oh, it's my first cup of coffee for the day, and it is so good. So we want to do some crop rotation, and I will, on the handout that I post on the website after we get done, I'll make sure and include a handout on crop rotations so that you know which groups to rotate with others. But for instance, if you didn't know, other vegetables that are in the Solanaceae family, which is the family of tomatoes, would include eggplant and bell peppers. Most people are pretty surprised about that. They don't realize that they're in the same family. And so those crops are going to share many of the same disease. They're going to be susceptible to many of the same diseases and even insect pests and even nutrient deficiencies. If you've ever had blossom end rot on a tomato and then you've had peppers planted in the same area or near it, you may have had blossom end rot on peppers before and didn't even realize that it was the same thing. So they share lots of similarities. Let's also throw out there things that would be in the cucurbit family. So this is going to include our cucumbers, our squash, melons, watermelons, cantaloupes, muskmelons, all of those fall into the cucurbit family. Zucchinis, I guess I should have said zucchinis. And then some other families would be our root crop families, brassicas, which are like leafy greens, and there are a few more. But let's just keep in mind that it's going to be good to keep these on a rotation. Even if we can't do it yearly, we need to keep it maybe on a 2 or 3 year rotation. And what this is going to do is, like I said, it's going to break the cycle. So say that you had verticillium wilt in your soil where your tomatoes were. And you knew that it was verticillium wilt. You're like, oh, can't plant tomatoes there next year because they'll get it too. So you decide to plant corn there. That's good because you're breaking the life cycle of that disease. It can't live on corn. If you grow a crop there that's not a susceptible host, you're breaking that life cycle. The next year you could come back and plant a healthy, clean crop of whatever your initial crop was, say tomatoes or something else that was in the Solanaceae family. So that's where crop rotation really, really plays an important role in cultural practices with organic and natural gardening. Next up, I wanted to make sure I mentioned cover crops. I feel like I'm spending the entire class on this one slide, but it's so important that I want to go into a little detail of each of these issues. Cover crops can do a lot of things for our soils. They can improve infiltration. They can reduce erosion by holding the ground and having constant cover. They can resupply our soil with nutrients if it is a legume crop that is fixing nitrogen from the atmosphere and delivering that back to the soil. So we can get lots of different benefits from cover crops, but the way that we can utilize them to help us control disease and pests is that just like breaking that life cycle for disease, we can break the life cycle for disease and insect by implementing cover crops during non-season like growing periods. So let's say that you had, let's say you were growing some cabbage and you had a big issue with like some cabbage loppers. And so you harvested that out, you decided to plant a cover crop on it, and we wanted to plant, say you planted a cereal grain, which is, you needed some more infiltration. Cereal grains have really good root systems. So you planted something like a wheat, a winter wheat over that area. Maybe you mixed in a little vetch to help produce some nitrogen. Well, what we've done here is introduced a non-host crop. So if you have larvae or eggs or even immature adults that were left over from that previous crop of cabbage loppers, they're not going to have anything to feed on. And so they're not going to survive. So you're breaking, again, that's just another example of how you can break that life cycle of that pest and be able to reintroduce your main cash crop the following growing season. And then it's also said there's not a lot of research-based information, but there is a lot of, we'll say, observances of certain cover crops actually being able to provide some fumigation qualities to soils, like radishes, and some of the turnips. So that we'll save that for another talk. We'll have a cover crop talk and get into details about that. Another cultural practice would be the use of trap crops. And not only can these be useful, but they can be very beautiful. Sunflowers are a great trap crop for pest type insects. They are drawn to sunflowers as well as many other flowers. But they can be, you know, a beautiful trap crop. You can plant these away from your garden area and try to draw those insects to that trap crop and away from your main edible growing area. So finally, weed prevention kind of goes back to sanitation, how we talked about that before. Weeds can serve as host plants for diseases and insects, just like our standard crops do. So I'm sure some of you are familiar with the weed. It's a nightshade. There's lots of different names for it, but a lot of people just call it nightshade. The bloom looks just like a tomato bloom, except it's kind of purpley and it has thorns on it and it can get pretty tall. It's in the same family as tomatoes. So if you have these weeds growing on a fence line, those insects and diseases that were thriving on your tomatoes, peppers, eggplants can just hop over and overwinter on some of those weedy species. So it's important to control weeds not only in the garden, but around our garden areas. And then finally, tillage. And you may be thinking, well, how in the world can tillage help us manage diseases and insects? Well, believe it or not, many insects lay their eggs and or larvae in the soil. They burrow down, lay their eggs in there. The eggs overwinter in that soil. If the soil is not disturbed, turned over, and exposed to light or allowed to be dried out, those eggs will survive, or those larvae will survive. However, if they're tilled, in many cases, turned over and exposed to elements, that can end their life cycle, and so we can be reducing some of our pest problems that way. Same way with diseases. So southern blight, for example, if it is turned down deeply enough into the soil, it can actually be buried and not affect what we're growing in the top 6 to 10 inches of the soil. So tillage can provide us some benefits as far as cultural practices go as well. Okay, good. I was just checking my time. We spent 30 minutes on the first slide. We're never gonna make it through. I'm just kidding. We'll make it. So then we're moving on from cultural practices for disease and insect management and moving on to some mechanical things. What are some things that we can do ourselves? You know, sometimes I don't feel productive unless I'm just really taking something into my own hands and taking action on that. And so this is your chance. Get out there with the hoe, girls and gentlemen, and get to work and get those weeds out of there and make sure you're sanitizing, keeping things nice and clean. We can do hand removal of insects. I know, you know, sometimes I'll see a hornworm on a tomato. I don't really like touching them, but I might get tweezers or a stick or something and knock it off on the ground and smash it. So hand removal is always an option if you're up for that. If you're not, pruning is always an option. Say that you have some particular shrub, one branch is being affected by a fungal disease and you don't want to treat with a chemical, you can prune that infected area out. And if it hasn't had time to spread, you may be nipping that in the bud. And the same goes for insect infestations on herbaceous plants. That could be a viable option for control, pruning out those infected areas and disposing of them away from your garden area. Sometimes you can just shake a plant. Like I have the common name is salt cedar. I can't remember what the Latin name is for it, but it looks kind of like a cedar tree, but it blooms out pink on the new ends. It's blooming right now, and it's deciduous. It loses all of those little needle-like leaves in the wintertime. And last year, the Japanese beetles ate it up, and it was the weirdest thing because when I say it blooms, it's not really like flowers, like a crepe myrtle or some of these other flowering plants that we associate Japanese beetles with, but it was just eating up that needly foliage like no other. I'm telling you, it was all over them. Well, I just went over there and gave it a good shake, and they all fell onto the ground, and then I sprayed them. So in the end, I did use a chemical in that type of situation, but I was just using that as an example where you can shake a plant in some cases, and those insect pests will dislodge themselves. I've never been able to shake a disease off a plant, or not yet anyway. We shall see. I may have to hone in on my shaking skills. But moving on from there is you can just use strong sprays of water. And I do this a lot for indoor plants. I'm not great at keeping house plants alive because I forget to water them. So most people's issue is overwatering. My problem is not watering. But when they get insects on them, and you can do this with other plants, just, vegetable plants or ornamental plants out in the garden, if they have highly concentrated numbers of insects on them, you can give them a strong spray of water and knock off a ton of them. Like this picture here on the bottom is the very top part of a pepper plant. And man, when aphids get in them, they just have a ball and they go at it. But you can get a strong spray of water out of the hose, or even, take them into the kitchen if they're still in their little pot. And I've rubbed them with my fingers and washed those off. And that's a good way to remove a lot of it. I'm not saying you're going to get all of it, but eradication is not the goal in organic and natural vegetable or gardening in general. Control to acceptable thresholds is what we're looking for. So strong sprays of water can be great. Barriers are another option that I feel are probably underutilized, probably because a lot of people just don't understand how they work or are skeptical that they work at all. And you will never know until you try, I guess. But this book is this book that I introduced y'all at the beginning. A lot of this information is research based, and they have references on where they got their information from. And these are some examples of some barriers that they suggested. I don't know, have you ever heard of using copper strips as a deterrent or a barrier for slugs and snails? So I've never really had a big issue with slugs and snails in the garden, but they can be voracious eaters, I hear, of foliage, and cause quite a bit of damage if you've got a moist, shady type garden area. So they say copper strips work well as a deterrent or a barrier until they become tarnished. And then that could be troublesome and a lot of work. You'd have to take those strips up and clean the tarnish off. Because once it gets oxidized, I guess whatever deters them from those strips is hindered, by that oxidation layer on there. So you have to clean those off. Laying barriers of sharp, crushed items. I don't know. I know a lot of people say eggshells, but I don't know if those are actually like sharp enough. You may need to use something sharper like crushed seashells. They mentioned several times burnt wood ash. Also diatomaceous earth, which is like very, very fine, sharp crystals. So laying barriers of that around plants as a protection barrier could be an option. We also have like collars, like small cardboard collars that you could put at the base of plants to protect them from, I know this sounds silly if you have like lots of herbaceous plants, but if you have valuable woody plants, you may think that it would be appropriate to put some of these cardboard collars around the base of your more valuable woody plants for vole protection, going up and chewing on the base of the plants, rabbits even. They suggested just saving your toilet paper rolls and cutting a slit in it and then wrapping it around, the base of those more valuable woody plants. That could be an option. Even using small collars at the base of like tomato plants can help deter cutworms because they crawl up from the ground. That's where their larvae, their eggs were laid in the ground, they pupate, they crawl out of the ground and straight up onto until they find a plant, straight up onto it and start eating. So barriers can be a great option for mechanical removal or prevention. Traps. I feel like traps are underutilized in residential gardens. They don't have to be insect specific even. You could just put out numerous sticky traps that are in different colors in different areas of your garden. And different colors actually attract different types of insects. And that's what this picture on this slide here is showing, is a yellow sticky trap. This one is in some cucumbers, and they're trying to attract cucumber beetles. So they can be very, very effective in the home garden. They're a good tool for monitoring to let you know when an issue is beginning to happen. So that could be a tool, an IPM tool that you use. But also, once they're trapped on there, they can't eat on your plants anymore because they're trapped on the trap. So, I mean, that's why it's called a trap. And then, of course, they make pheromone traps for lots of different insects as well. I will discourage you, however, from using Japanese beetle pheromone traps because they draw in insects to that trap. And not only are they drawing insects from your garden into your trap, but they're drawing insects from your neighbor's yard to your property. And maybe they go in the trap, or maybe they land on your plants. So that really isn't one of our recommendations as far as Japanese beetle control. If you are going to use them, the proper way to use them would be to place them away from your garden. Don't put the trap right under the crepe myrtle that it's eating right all over. You want to draw them away from those plants. So you want to make sure you're careful on placement of pheromone traps. Floating row covers can be super effective at mechanical, we won't say removal, but exclusion of pest insects, especially for leafy crops and even root crops that don't require pollination to produce their end fruit. We can keep those plants covered from the time that they germinate to the time we harvest them because pollination is not necessary. We don't have to be concerned with taking the row covers off and letting the bees come in and pollinate and then making sure they get out before we cover it back up. So cabbages, lettuces, carrots, even lots of those cold crops or cool season crops that many people like to refer to them as, they do really, really well with using floating row covers. Now, the trick to making sure that they work is that they're anchored down. You can't just like toss it over it, but leave the sides like flapping, right? So we're going to need to find some way, either some stakes to stake it down. I've seen people fill up used water bottles, just fill them back up with water and lay them all along the edges to help weight down those floating row covers. The floating row covers are light and thin enough that they allow water and sunlight through them. So the plant, and air circulation as well. So the plant can grow naturally up underneath that row cover. We just want to make sure that we put it on there loosely enough to allow for the growth. You don't want to like cinch it in there real tight and then it grows and is like, you know, cramming its head up against the top of the row covering and can't get out. We just want to make sure they're laid on there real loosely. And then finally, for mechanical control that we can use at a homeowner level is the use of mulch. I know I feel like every talk I get, I stress how important mulch is. In the weed talk I gave a few weeks ago, one of my main methods for weed control is the use of mulch. Another really awesome thing that mulch does for us is helps maintain soil moisture levels and soil temperature levels, which can be important during droughty seasons in the summer. Can also be important during winter months when we have freezing conditions and the ground is experiencing that freeze thaw situation and trying to heave plants out of the soil. Mulch can really help to kind of even all of those conditions out. So another great thing that mulch can do for us is it can help prevent insect control. I mean, not insect control. Well, it can do insect. Well, first we're going to talk about disease control. So if you have mulch put down underneath, say, your tomato plants and it rains, instead of the water splashing onto bare soil and splashing up soil particles that could harbor potential disease spores and infect the leaves, if you put mulch down, you've taken that out of the equation. You're taking that rain splash out. And believe it or not, that is how many of our tomato diseases start. I'm sure you'll see on yours, if you've ever grown tomatoes, that firing up that everybody calls it, where it starts at the bottom, the leaves get all crunchy and it just starts moving up the plant. that started from a rain splash from your soil that infected those bottom leaves. So let's use mulch to prevent disease. And then you can also use some mulches like plastic mulch. Believe it or not, when people put out plastic, that's called plastic mulch. That can serve as a barrier that doesn't allow insects to get into the soil to lay their eggs and larvae. Remember some of those that I was telling you about? They burrow down, lay their eggs. If you have a plastic mulch barrier on there, they can't get down there to lay their eggs. So it's kind of a 2 or 3-fold advantage there with using mulch. So now we're going to move on to biological. And if you have questions as we go along, please type them into the chat box. I see a few people have put things in there, so that's great. But if you have thoughts or comments that you want to add as we go along, just put them in there and we'll talk about those at the end. So now we want to move on and talk a little bit about biological control. And I don't want to confuse you with a lot of terminology, but I do want you to know what this means, okay? So biological control is utilizing living organisms to kill pests, whether those pests are insects or diseases. So we'll throw some examples out there. Beneficial insects. Goodness, I could do 3 whole talks just on beneficial insects. We could focus on pollinators. Then we could have one on predatory insects. Then we can have one on parasitoids. There is such a wide gamut of beneficial insects. And believe it or not, there are more beneficial insects that are visiting our plants than there are pests. Now, usually we only recognize the pests because they are causing some kind of issue with us, right? The beneficials are just making the plants happy, and that makes us happy. And so we don't tend to notice them quite as often unless they are a beautiful butterfly or a beautiful butterfly caterpillar. But we can do things to encourage the presence of those beneficials in our gardens. We need to be able to recognize who the good guys are in their adult forms, in their larval stages. We need to be providing them habitat. So providing food for nectar plants, providing food for those that require host plants for their immature stages of their life cycles. So in doing things in our garden to promote and encourage and attract beneficials to our garden are going to help us fight the battle against the bad guys, if you will, or the pest type insects. Also, birds. A lot of songbirds love munching on grubs and other worms and lots of other insects out there. So it could be beneficial for us to do a little self-education on maybe how to attract some of those insect eaters to our yards. Toads. I don't know if you've got maybe a pond, whether it's ornamental or just a small fishing pond at your home. But toads are great. They love to eat all different kinds of insects. However, they like to eat pest insects, but they'll also eat good insects as well. I've seen one eat a butterfly, and that's kind of sad. So beware. Microbes. So I throw this out there. There is a product called Bacillus thuringiensis, okay? And it's found naturally occurring in nature. It's a microbe, and you can apply this to certain plants, and it will control a very narrow spectrum of insects. So it wouldn't be what we call a broad spectrum insecticide where you apply it and it kills everything. Bacillus thuringiensis is very specific. And we're going to get into some more specifics on that here in a minute. Another thing that we could do for biological control would be to release parasites and predators, which would fall underneath the beneficial insects category. So we could, but if you want to get realistic about it, you can order these online, have them shipped to your house. If you go out in the garden and you release a whole box of lady beetles, the likeliness of them staying is not very good. So they're probably just going to fly off, right, to someone else's lawn or garden. But where they could be useful is if you have a small home greenhouse, high tunnel, low tunnel, some kind of enclosed area is where we're going to see benefits from releasing parasitoids, parasites, predators, and even pollinators in many instances. I know a guy who raises strawberries in a greenhouse, and he releases bumblebees in his greenhouse to help pollinate his strawberries. So some other types of things, beneficials that may be released in these enclosed areas, there are parasites for whiteflies. Whiteflies always seem to be an issue in enclosed growing spaces. There are predatory mites that prey on spider mites, and spider mites may very well be the bane of my existence. They just drive me crazy. Aphids, there are several different aphid predators. There are even fungal gnat predators that would be beneficial to release in enclosed areas. So lots of different things we can do there. So let me check my time. We don't have a lot of time. So I'm going to scan through some of these slides, and if we want to at a later time, we could have a talk just on different types of beneficial insects and the things that they can provide and bring to our garden. But here's a quick little overview. So ground beetles, believe it or not, they're predatory insects. They provide lots and lots of benefits to us. They eat armyworms, cutworms, lots of different grubs that are in our landscaping and lawn type areas. Of course, everyone knows that lady beetles are great. We advocate having those in the garden. Ambush bugs look scary. They're this one here in the center. Let me put on my little pointer thing. Pen, laser pointer. It's right here. That's our ambush bug. They'll eat almost anything, good or bad. Lacewings, so pretty, and they like to eat aphids, mites, scales, lots of different soft-bodied insects, and the same thing goes for the hoverfly. So believe it or not, we have some flies that are beneficial and not just annoying. Now I don't know how to get the pointer off. Holy moly. There we go. A few more. Now we're still talking about predatory. So we have the wheel bug that's right. Well, actually, this is the wheel bug. This is the wheel bug right here. You can see it's called wheel bug because it has this little kind of wheel-shaped thing on the top of its thorax. Some people, well, it is a type of assassin bug. It's a true bug. It falls in the family of true bugs, and so does this one right here. This is the milkweed assassin bug. That's a predator. We've got praying mantids, we all know are great predators, and the orb weaver spider, which is a great all spiders really are great predators of troublesome pest type insects in the garden. So it's good. Don't try to kill all your spiders because they can do good things for us. We also have parasitoids out there. The tachnid fly is the one that you see right here. He parasitizes small larvae, worms, caterpillars, other things like that. Blue-winged wasps, they are solitary wasps that live in the soil. So if you ever see a really pretty shiny blue wasp coming out of the ground, don't get out your wasp spray. They do good things for us. Brachnoid wasps, that's what this one is right here, this red one with the black wings. They parasitize hornworms and lay their eggs all over them. So if you come into contact with a hornworm that has all these little white egg masses on it, don't kill it, because those eggs are feeding off that hornworm, and pretty soon you're going to have a whole bunch of brachnoid wasps that come out of these eggs and are going to help you fight the battle against your hornworms. And then potter wasps can be beneficial also. They parasitize lots of different types of caterpillars. And then I like to play this game called Friend or Foe. We don't have a lot of time to do that, but this is just to show you the importance of being able to identify insects that in their different forms. So their immature forms and their adult forms. I know this was a sad thing, but I like to tell it when I talk about this story because she had a bunch of caterpillars and they were all over one of her vines, and she picked them all off and killed them. And then a few days later, she realized that they were monarch caterpillar. And so that was sad. So it's important for us to be able to recognize many of these different insects and their different life forms. So the one here on the top right, we talked about the lacewing. This is what it looks like in its immature stage. If you see this, it would be beneficial for you to know that this is not a pest insect. When we talk about the lady beetle, its immature form looks like a little black alligator with orange spikes on its back, kind of in a circular pattern. Stink bugs, they look kind of like funny little ladybugs. If you were just taking a little quick glance at them, they're kind of orange and black, and they have black stripes across the tops of their backs, and then they also have little black stripes around the perimeter of their abdomen. Now, there are more types of ground beetles than there are any other type of insect. So there can be many, their larvae can appear in many different forms. There's no way that we could teach ourselves all those, but this is an example of what a larva of a ground beetle may look like. And then, of course, if you see this large, it's a really big brown moth. If you ever see that, then you know that you had hornworms in the past, or that they're fixing to lay some eggs and you're gonna have some hornworms pretty soon. So keep an eye out for large brown moths. So now, before we get off, we've got a few more minutes and then we'll do a little bit of discussion. I briefly want to talk to you about some different types of insecticides, and we're focusing on things that are OMRI listed. If you see the initials OMRI on them, that means that they are certified for use in organic growing, certified organic growing. So IGRs, and remember we talked about we want to find the path that is least harmful, right? We want to be as specific as possible. And IGRs, or insect growth regulators, allow us to do that. Insect growth regulators are very specific to certain types or families of insects, and they interrupt their life cycle at a specific point, like chitin production. That's like the exoskeleton of a beetle. If it inhibits chitin production, that insect can't molt or pupate into its next life stage, and basically it dies because it can't follow through with its life cycle. So that particular IGR would be very, very safe for mammals because we don't have a pathway that produces chitin, right? We don't produce chitin because we don't have exoskeletons. So that is, I'm just trying to give you a few parallels so that you could understand what these different types of insecticides are and why they are considered OMRI. So that would be an example of why. Soaps and botanicals, many of them are labeled OMRI. Now, botanicals are things that are derived from nature, whether that was plant-based or, but it came directly from nature. It's not something that anyone made. So insecticidal soaps, pyrethrins, plant oils could all fall into these areas. Mostly these types of insecticides are going to target soft-bodied insects like mites and aphids, and they can spare hard-bodied insects like ground beetles and lady beetles. So again, we're being very specific. We are narrowing the range of insects that are affected by the product that we are applying. So that is how we could use those effectively. Oils, many horticulture oils, I'm sure you've heard of that, or a dormant oil. They disrupt cell membranes and they kill through slow suffocation, which sounds like a horrible, horrible death. And they can be phytotoxic to some plants. So let's be careful when we're using dormant oils or horticulture oils, especially on evergreens, because if they are applied and then exposed to a lot of sunshine, they can actually burn that foliage material on that plant. So we'll be careful with oils. And then there's another category called biorational insecticides, and those are like the BTs, the Bacillus thuringiensis that I talked about before. They are very target specific, and in this case, they target only the Lepidoptera family of insects. That includes moths and butterflies. Diptera, that targets flies and mosquitoes, Coleoptera, that targets beetles, and Hymenoptera, which is wasps and bees. So even though it is very specific, it can still, while we're using it to control a pest insect, could be very harmful to some beneficial insects, whether that be our ground beetles we discussed, or our pollinating bees, or even our pollinating butterflies. So we need to be careful when we're using those products. And then a final word before I move on and talk about fungicides is just want you to understand the difference in systemics and broad spectrum foliar applied products. If something says that it's systemic, it's less likely to affect predators on plant surfaces because they are not feeding on the plant. A systemic insecticide is absorbed into the plant, and when a pest insect feeds on that plant and they ingest it, and then it affects them. Now, if you have a beneficial insect, say like the caterpillar of a butterfly that eats foliage, you would not want to use a systemic insecticide on that plant because when they ingest it, it could then, affect them. But for the most part, say you wanted to preserve your lady beetles, but you're having problems with aphids. You treated with a systemic. When the aphids sucked on the plant juices, it killed them. However, when the aphids were there when the lady beetles were there feeding on the aphids, it didn't have any effect on them because they aren't eating plant foliage. So I hope that makes sense. Now, broad spectrum insecticides are sometimes necessary if multiple types of pests are present at one time. An example of a broad spectrum insecticide would be a pyrethrin, and pyrethrins can be derived botanically, and many of them are labeled OMRI, so you could use them in organic gardening. However, that does not mean that they are safe or that they will not harm beneficial insects. I want to read you this little excerpt from the book that I introduced y'all at the beginning. It says, "Beware these botanicals. Historically, botanical sprays like rotenone were mainstays of organic pest control, but times have changed. Experience and research have shown that many botanicals are very toxic, not only to pests, but to bees and other pollinators, birds, fish, and even people and pests. For these reasons, sprays and dust that contain nicotine, sabadilla, ryannia, or rotenone are no longer recommended for use by organic home gardeners in any circumstances. Pyrethrins and neem oils appear to be less hazardous, but even they should be reserved for use only as a last resort because they're broad spectrum. Many botanicals are listed as allowed with restrictions for use in organic crop production under National Organic Program, NOP, which converts to OMRI. Nicotine is strictly prohibited. Certified organic growers should carefully review these regulations before using botanical poisons." So I just thought that was a neat little excerpt to help you understand that even though these are labeled OMRI, that does not mean they're safe, okay? So we still want to look for the least impactful product to use to control our issues. Fungicides, I promise, give me like 3 more minutes. I know I've gone past 1 o'clock, I'm so sorry. Fungicides, want to introduce a few things here. Bacillus subtilis might be familiar to some of you as the product name Serenade. It is a live bacteria, so we need to be careful on storage for some of these products. We want to make sure they don't get too hot or too cold. Store them in a nice room temperature because we don't want to kill that live bacteria before we have a chance to use it on the plant that we want it to combat that whatever disease that is. Serenade can control bacterial blights as well as fungal blights like powdery mildew, downy mildew, late blight, things of that nature. Coppers are OMRI. You can find copper and sulfur products in a lot of different formulations, powders, kind of like a granular that dissolves. You can even find it in a liquid formulation where that you can mix and spray on plants. So those are very useful for fungal control. Neem oils, not only does neem oil show to control some insects, it also has some fungal activity. Not a lot, but some. Potassium bicarbonate, Monterey Old Fashioned is one product. That's the one right here where my little cursor is. That's a kind of like a powder, and you mix it in water and it dissolves. That controls powdery mildew and lots of different types of leaf spots. Streptomycin is kind of hard to find. That would be this mycostop right here, and I'm not actually sure if that's available anymore, so we'll scan over it. And then sulfur products, we already talked about many of the sulfur products that are available on the market. And then herbicides, just quickly, because I know this isn't a weed talk, but there are some products that we can use for weed control. Acetic acid products. Please don't mix things from underneath your sink or try to come up with your own homemade formulations. We are not, we are not conducive to those types of recommendations, but there are some products that that are derived from acetic acid that you can use for weed control. There are some herbicidal soaps. There are some botanical herbicides like limonene that comes from plants. And then some other natural oil products like cloves and things of that nature. And what we run into with these organic herbicides is that they are not selective. So whatever you put them on, they're gonna try to kill it, and they don't last very long. So you're gonna have to do repeat applications, like a lot of them. And they're more effective on annuals than they are perennials. And then that was my last slide. We have lots of different resources. If you go to uthort.com, which I encourage everybody to go to, that's where we're housing all of our horticulture publications. You can get a lot of this information. We have a brand new publication. It's called Conventional and Organic Product Overview for Home Vegetable Gardeners in Tennessee. So you could just type in the keyword organic or vegetable garden, and it'll be in the list that comes up. You could also type in the pub number. That's W661. That's going to be a great resource for you if you're looking for organic products to help you with insect and disease control. Another one that I highly recommend that you read just as a baseline to get some basic knowledge a little deeper of some of these things we talked about today. It's called An Introduction to IPM of Landscapes, and it is publication SP 503-D. Those would be my top two, but of course we've got some more here. Home vegetable garden insect control. You can control garden insects, garden disease control, but those all focus more on traditional gardening control methods and synthetic pesticides. But you can find everything you need in this conventional and organic product overview. So that is all I have for y'all today.